An introduction to functions, terminology, examples. In this video, we will look at examples for how to determine domain, range, and asymptote values. What is the domain of a function? The domain is the set of the first coordinate from each of the ordered pairs in a relation. This means only the x values in a relation or function. What is the range of a function? The range is the set of the second coordinate from the ordered pairs in a relation. This means only the y values in the relation or function. What is an asymptote? The asymptote is the line that a curve of a function approaches more and more closely but never reaches. Example number 1. Determine the domain and range for this relation. Is this relation a function? The relation is given as y equals 2x minus 5. Here is a graph that represents this function. This is a straight line, which makes it a linear function. There are no restrictions on the values that can be chosen for x and y. This means that the domain is the set of x such that x is an element of the real numbers. The range is the set of y such that y is an element of the real numbers. There are no asymptotes as there is no curve. Example number 2. Determine the domain and range for this relation. Is this relation a function? Y equals x minus 1 squared plus 3. Solution. This is a parabola which represents a quadratic function. There is no restriction on the x values, so the domain is the set of x such that x is an element of the real numbers. We can see that in this graph. Example number 2. The parabola has a minimum at its vertex of 1, 3. All values of y are greater than or equal to 3. The range then would be written as the set of y such that y is an element of the real numbers and y must be greater than or equal to 3. There are no asymptotes. Example number 3. Determine the domain and range for this relation. Is this relation a function? Are there any asymptotes? Here is the relation. Y equals 1 divided by x minus 4. The solution. You cannot divide by 0 as it is undefined. That means that x minus 4 cannot equal 0. That means x cannot equal 4, since 4 minus 4 is equal to 0. The vertical asymptote is at x equal to 4. That gives us a domain, the set of x, such that x is an element of R and x cannot equal 4. Now, we cannot have a division by 0, so the asymptote y cannot equal 0. that will give us another asymptote at y equal to 0, meaning the range would be the set of y such that y is an element of the real numbers and y cannot equal 0. After applying the vertical line test, this equation represents a function. Here is example number 4. Determine the domain and range for this relation. Y equals the square root of x minus 1 plus 3. Here is the solution. The expression under a radical sign, which is the square root sign, must be greater than or equal to 0. In the square root of x minus 1 plus 3, x minus 1 must be greater than 0. To make that true, x must be greater than 1 or equal to 1. So the domain would be the set of x such that x is an element of the real numbers and x is greater than or equal to 1. The value of the radical is always 0 or greater. The value of the radical is added to 3 to give the value of y. Therefore, the y values will always be greater than or equal to 3. So our range would be the set of y such that y is an element of the real numbers and y is greater than or equal to 3. Coming in the next video, function notation.